Welcome to Scriptico. Today, we're diving into the world of Python generators. These powerful tools allow lazy iteration through sequences, making them perfect for handling large datasets or streams of data efficiently. Let's explore how to define and use them, and see their benefits in action. To define a generator, use the def keyword just like a normal function. But instead of return, we use yield. This keyword produces a value and pauses the function's execution. When resumed, it continues right after the yield statement. When you call simple generator, it doesn't run the code immediately. Instead, it returns a generator object. This object has an internal method named next, which is used when we iterate over the generator. Generators offer several advantages, significantly enhancing code efficiency and readability. Let's explore these benefits in detail. Compared to lists that load all elements into memory at once, generators produce items one at a time, only when required. This optimizes memory usage. With the list, all 1 million numbers are stored in memory at once. But with the generator, numbers are produced one at a time, reducing memory usage. Generators enhance performance by producing items on the fly. They can start yielding results immediately without waiting to process an entire dataset. With the list, we generate all the numbers and then process them, which takes more time. However, with the generator, each number is processed as soon as it is generated, making the process more efficient. Generators help in writing clean and readable code. They allow us to define an iterative algorithm simply, without boilerplate code to manage the state of the iteration. With the list approach, we read all lines into memory at once. With the generator, we read and yield one line at a time, making the code simpler and more readable while saving memory. Now, let's explore some practical use cases where Python generators excel, simplifying complex tasks while optimizing performance and memory usage. Generators are excellent at handling continuous streams of data, like real-time sensor data, log streams, or live feeds from APIs. They process data as it becomes available without storing large amounts in memory. In this example, the datastream method generates data at intervals, simulating a continuous data stream. The stream processor processes each piece of data as it arrives, demonstrating how generators can handle streaming data efficiently. Generators provide a straightforward way to define and execute iterative algorithms that involve repetitive calculations and simulations. They maintain the state of the iteration without manually managing loop variables. The Fibonacci generator method defines a generator that produces Fibonacci numbers indefinitely. It returns each Fibonacci number one at a time, starting from 0 and 1. The for loop iterates 10 times to print the first 10 Fibonacci numbers, demonstrating efficient sequence generation. In the following example, we'll simulate real-time updates of a stock price. The generator will produce a new stock price at each step, based on the previous price and some random fluctuation. This example generates each stock price on the fly based on the previous price and doesn't store all generated prices in memory, making it efficient for long-running simulations. The generator provides a new stock price at each step with minimal computation. In summary, Python generators offer efficient memory management and enhanced performance, simplifying code while tackling diverse tasks like stream processing, iterative algorithms, and real-time simulation. Their ability to optimize resources makes them a valuable tool for modern Python developers seeking elegant and scalable solutions. Hopefully, this exploration of Python generators provides you with the insights needed to leverage their full potential. Don't forget to subscribe to the channel for more tutorials and see you in the next video.